So in this video, we'll look at 1.10 and 1.11. So 1.10, we have this pizza up here. And be really careful between diameter and radius. That's one place where a lot of people get messed up. It says the diameter, 16-inch diameter pie. The radius then is 8 inches. That's the number we want to use. So I wrote here, right, 8 inches from here to here. They break it up into 8 equal pieces. And we want to know, is this shaded area more than a normal slice, right? The idea is Lee cuts off this little part right here and eats the shaded area. I guess he likes crust or something. And you want to know, is this shaded area more area than one of the triangles? Okay, now you should all know the area of a circle is pi r squared. So the area of one of these guys here, the regular one, is 1/8 pi r squared, where r is 8. So that's how much a normal piece is, and you want to compare that to the area of this little shaded thing. Now there's no real formula for the area of a shape like that. It's not like you just look it up or something. So instead, and this is a common trick, it's like a common trick on SAT tests and everything, instead you just subtract out what you know. Okay, so you use what you know to figure out what you don't know. So we indirectly figure out the shaded area. So here's what we do know. This whole area, this big piece here, is 2 times this, right? So this area here, I'll outline it in blue, right? 2 pieces of pie, 2 pieces of pizza is 2 times 1/8 pi r squared. So that's easy to figure out. Just figure out whatever this was, do that once, and now we have 2 of those pieces. And then what we can figure out is the area of these triangles. Okay, and then we can take this thing, the whole piece minus the area of the triangles, and that's what the shaded area is. So that's the trick here. The whole piece minus the area of the triangles. In other words, we're going to take this whole piece here minus the area of the triangles, and that equals this piece, right? Isn't that cool? I just thought that was pretty clever. Do it that way. Yeah. Okay. So we know this. This is, let's see, 2/8, 1/4 pi r squared. So we got to figure out the area of the triangles, but that's pretty easy. The hypotenuse is 8. We know these two sides are the same because this is 45 degrees, which means this is 45 degrees. So we know it's an isosceles triangle. So a 45-degree triangle, which means that this side here, let's call it D, and this side here, which is D, call that D. We know they're the same because it's a 45-degree triangle because this line cuts directly in half, right? This is 90 degrees, cuts directly in half. And we know that now we can just use the quadratic formula, not quadratic formula, Pythagorean theorem, and figure out what D is. So we know that D squared plus D squared is equal to 8 squared. So we can figure out what D is now. I'll let you guys do that. So now, after you figure out what D is, we can figure out the area of the triangle, because the area of a triangle is 1/2 base times height. The base is D, the height is D, that's really cool. So that's 1/2 D squared. Now we have 2 triangles. So 2 times the area of the triangle is just 2 times 1/2 D squared, which is just D squared. So up here, really all we need to find is D squared. And then D squared is the area of this thing here. So this thing here is D squared. And so we take away 1/4 pi r squared minus D squared equals the area that we want. And then you compare it to 1/8 pi r squared. And I guess that looking at the answers, this shaded piece is a little bit bigger. Who'd have known, right? You should get that it's a little bit bigger. Okay, so that's how you do that. So it's kind of like those problems come up a lot where you solve them indirectly. Really good skill, really common on tests and stuff, standardized tests. So, okay, so I think you can carry it from there. Now let's look at 1.11. I'll look at 1.11 over here, 1.11. So here they talk about DNA, and we're just trying to figure out, it's kind of cool fact that every bit of all the DNA in one cell in your body is about 2 meters long. It's pretty amazing, right? If you took the DNA from one cell in your body, it's about 2 meters long. And the human body, they're saying, has about 10 to the 14th cells. Okay, so basically this problem is 10 to the 14th cells times 2 meters is how much, and compare that to how many times it would go around the Earth. Okay, so of course we need to know the crater of the Earth. How big is the crater of the Earth? And you can Google that. I mean, it's easy to find out the circumference of the Earth at the equator. I just remember from doing a lot of these problems before that at the equator, the radius is about 6,400 kilometers. It's a little bit less than that, but it's close enough, about 6,400 kilometers. So the circumference is 2 pi times the radius. So the circumference is 2 pi r. However, we need to change that to meters because we have meters here. Okay, so that's 2 pi times 6,400 with 3 zeros. So 6 million meters. That's the circumference. We take this number here and divide it by that, and that's about how many times it goes around the Earth. So that's all they want to do. You take the number we have, divide it by this number. So this is 2 times 10 to the 14th. So the number of times it goes around the Earth, the number of times it goes around the equator, is how long it is, 2 times 10 to the 14th. And we have meters here, and we have meters here now. So we don't have to worry about units. We know they're gonna work out. So 2 times 10 to the 14th divided by 2 pi times 6,400,000. Okay, and if you do that, and I'll leave that as an exercise to you, you should get their answer, which is about 5 times 10 to the 6th. What's that, 5 million? It should end up being about 5 million times. 10 to the 6 is a million, so yeah, about 5 million times, roughly. Okay, if you get 4.8 million or 5.2 million, close enough. This number is not perfect, so, you know, and it's not exactly 2 meters, you know, it's just close enough. So you should get about that. Okay, I'll leave that for you to do. It's a really good exercise to get used to doing scientific notation on your computer, on your calculator. It's hard to put in 14 zeros here, or 2 with 14 zeros. So practice doing that. Google how to do it if you don't know how to do it. But that's a good exercise to do. Okay, hope that helps. Good luck, you guys.